Okay. Let's start with hyperbolas. So hyperbolas have this sort of equation. Y equals to some k with x minus h. Actually, I'm going to put a there. A over x minus h plus k. So the simplest form is when a equals to 1, h equals to 0, and k equals to 0. And that gives you y equals to 1 over x. And this is the simplest type. This and this. Okay?
Yeah.
Now, one thing that I need to tell you is if a is positive, then you're going to end up getting this part and this part. If a is negative, then you will end up with getting the graph on the second quadrant and the fourth quadrant. And of course, this part will be the asymptote. That's the asymptote. That's asymptote here. And that's asymptote here. Now, h and k represent horizontal shift. So if h, so for example, if I want to do y equals to 3, x minus 2 plus 1. So how do I draw that? I need to first recognize that a is positive, right?
Yeah.
So I need to just pay attention to this one here and this one here. So it is plus 1, so it is elevated up by 1.
Yeah.
So that's 1 here. Now it's negative 2. Now when that's negative 2, it is actually going to the right.
Yeah.
So let me tell you something. If this is plus 1, it's going up by 1. If it's negative 1, it's going down by 1. If it's negative 2, then it's going to the right. If it's positive 2, it's going to the left.
Okay.
Yeah, so this one, it just works the opposite way. You can ask why that happens. Let me just kill this one. It is popping up constantly. Yeah, so now all you got to do is recognize that, all right, so this is our new quadrants there. First, second, third, and fourth here.
Right. Okay.
And this is 3 positive, so it's going to be in the first quadrant and the third quadrant, right? But we don't know whether it's going to go through these positive intercepts here in here, or so for this section here, it doesn't matter really how you draw it because there is no intercept going on, right? So you can draw this, so this is a bit more schematic diagram. It's not in scale. So in Year 11 maths, it's very important that you know how to graph a lot of things, but they don't have to be in scale. All right?
Okay.
It just has to be a schematic, means rough sketch.
Mm-hmm.
So this is 1 here, but this is like if that's 1 is around here, right? That should be 2 should be around here, but I chose that point as 2. It doesn't matter really. Okay.
Oh no.
Yeah, it's not in scale. So now we just need to figure out, I'm just going to plug in 0 there, okay? So y equals to 3 over negative 2 plus 1. So that gives us negative 1.5 plus 1, right? So that's 1.5, true?
Yeah.
So that's equal to negative 0.5. What that means is that when I have x equals to 0, y value is negative half. That means 0, negative half here. That's the y-intercept. You know how when you plug in x equals 0, then you find the y-intercept. When you plug in y equals 0, you find the x-intercept, true? Did you know that? Are you there, Natalie? Hello? Okay, so did you know this one here? when you plug in x equals 0, you get the y-intercept. When you plug in y equals 0, you get the x-intercept. Hello, are you still there? Is my voice breaking still? So we've got, yeah, just going to resume now. So this point here is a point that is on this curve. We found that point simply by plugging x equals 0, and the y value is -12. So this point is literally 0, -12. So the curve should actually go like this. It should go through that. But so if it goes through that, then it should go through that. And we can also find that point. That's x-intercept, isn't it?
Yeah.
Still with me, right?
Yes.
So we can find that point. So this point here, it was -12. We can find that point by plugging y equals 0.
Yeah.
0 equals to 3 over x minus 2 plus 1. You can solve this by moving this one to the other side. You get -1 equals to 3 over x minus 2. X minus 2, 3 over -1. So you can simply switch these two.
Yeah.
So x minus 2 equals to -3. X equals to -3 plus 2. That's -1. So that point there is -1. And that's the end of this graph.
Oh, okay.
Okay. So
It's pretty straightforward.
yeah, that's pretty straightforward, right?
Yeah.
Now, I'm going to introduce you to something like this. This will definitely be in the exam.
Right.
If you have x minus 2 over x minus 3, then how do you draw this? This is also a hyperbola.
Oh.
Okay. So just have a look. If you have a constant, let me just classify things. So it's a classification of hyperbolas. If you have a over x minus h,
Yeah.
this one always has the horizontal. So the horizontal asymptote is y equals 0. That means you have this curve with the horizontal asymptote here, because this is plus nothing, right?
Yeah.
So there's no elevation. And then you have some h somewhere. This is h. Could be there, could be here as well. Depends on what the value of h is. Anyway, so next part is y equals to a over x minus h plus k. So the horizontal asymptote is not y equals 0.
0, yeah.
It will be elevated or depressed, right?
Yeah.
Elevated, moved up or moved down, right? So it'll be like that or like that. Then you have another kind, which is y equals to some kind of like another linear function here, like ax plus b over x minus h. This is also that type here. And I'll show you the reason why. This one here, you need to make this one, so they have to be a little bit clever. X create this -3. See how the denominator is x minus 3?
Yeah.
So create -3 and then add that up and then -2. So I just created that and then I annihilated that. So you just put that in, it preserves the original, doesn't it? Does that
Yeah.
make sense to you? Yep. And what you can do is separate the fraction into this part and this part.
Right.
Then you get x minus 3 over x minus 3. And then plus,
Plus.
that's actually plus 1, isn't it?
Yeah.
That's 1 over
x minus 3.
And that's 1, isn't it?
Yeah.
This reduces down to x minus 3 plus 1.
Uh-huh.
Oh, we know how to graph that one, right?
Yeah.
So that one is equal to 3 to the right. That's 3 there. That's 1. And then it's a hyperbola.
Mm-hmm.
So it is here. Another one here.
Oh, so you don't have to find out the intercepts. You can just. Oh wait.
No, we do for this one, of course.
Yeah.
So we can find intercept by plugging in x equals 0.
Mm-hmm.
1 over negative 3 plus 1, that's still positive, right?
Yeah.
That's 2 on 3. So y-intercept is 2 on 3. So we get something like that instead. So previous case, we had, if we look over here, it was like that, right? Because the y-intercept was negative. But here, y-intercept is positive. Okay, over here.
Yeah.
Because when I plug in x equals 0, it's negative 1 on 3 plus 1, that's 2 on 3.
Yeah.
So this value is 2 on 3.
Okay.
And in a similar way, you can figure out the x value there as well by plugging y equals 0.
Mm.
And that's pretty simple. You don't have to solve this equation. That's a lot difficult, but let's try that. Let y equal 0. The negative 1 is equal to 1 over x minus 3. X minus 3 equals to negative 1, because you move that one there.
Yeah.
And move this one there. 1 divided by negative 1 is negative 1. X minus 3 just goes over there. And this is equal to negative 1 plus 3. So this is equal to 2. So x is equal to 2 here. So that's 2 over here.
Cool.
Well, this is a lot simpler if you just look at that one there, original function.
Yeah.
But this is 0. And you multiply both sides by x minus 3.
Yeah.
Multiply by x minus 3. 0 times by x minus 3 is still 0. This
Mm-hmm.
one cancels. So you get 0 equals to x minus 2. So therefore, x is equal to 2. So you get 2, 0 here.
Cool. So when I do that, I need to find first the asymptotes.
Yeah,
And
so when you do the hyperbolas, the most important thing is the asymptotes.
yeah.
So if
And
you
then,
just know,
yeah.
yeah, so need a few things. So you need the asymptotes.
Uh-huh.
I would say that's number 1.
Yeah.
Once you figure out the asymptotes, then you have to figure out the orientation.
Right.
It'll either be here, here, or here, here,
Yeah.
right? So you get this one, or this one, okay? That's orientation. Number 3, the intercepts. Which is, you do that by letting x equal 0, y equals 0. Are you still there?
Yes.
Okay, so that's how you do it.
Cool.
So we're gonna try a couple of questions here.
Sure.
So in the exercise, we'll sketch this graph. It's pretty simple, right?
Yeah.
So I'll show you how to do the last one here.
Okay.
So how do you graph this one? Okay. All right. Asymptotes are 3, negative 4. So 3 here.
And then
That's 3. The positive 3.
positive 4 as well.
Negative 4.
Oh, negative. Okay.
Yeah, negative 4. Like this. Have to make the graph a bit longer, because that's our new coordinate system now. That's negative 2.
Yeah.
So it'll be here and here, okay? So it'll be like that,
Oh.
and it'll be like that. But we don't know whether it's going to be like this or like this.
Right, so how do you define where the orientation is? Is it because it's
Because of -2, because if it's if A is positive, then you
oh yeah.
if A is
Yeah.
negative, oh sorry, if A is positive, you get this one. A is negative, you get this one.
Get that. Okay, cool.
So if -2 there, so it's like that and that here.
Yeah.
Second and fourth quadrant, and you plug in 0 there, see what you get.
My
-2, -3, -4. That's a 2 on 3, -4. That's negative, right?
yeah. Uh-huh.
So because 2 on 3 is such a small number compared to 4, so 2 on 3 minus 4, that's -10 on 3. So the y-intercept is -10 on 3.
Cool.
That's what we just found out.
Yeah.
We can find, of course, the graph is going to go like that. Surely the x-intercept is going to be positive. True? It's guaranteed to be positive. It cannot go like that and then that and that,
Yeah.
That's impossible.
Okay.
So if you plug in y equals 0, 0 equals to -2 over x minus 3, -4. Plus 4 there, you have 4 equals to -2 over x minus
Yeah.
3. And then you swap these two, you get x minus 3 equals to -2 over 4. And that's equal to -12. So x is equal to 3 plus 3 minus 1/2. So that's equal to 5 on 2, I guess. Yeah, if you take the calculator,
Wait,
3 minus, that's 5 on 2.
yeah. If you bring the back to like the third step, if you bring the x minus 3 to the other side, wouldn't you have to, or do you times it, or do you?
Oh, when you have a equals to b over c, you can change that to c equals to b over a.
Okay, without
So
changing any of the signs.
yeah, I swapped this one and this one.
Okay.
Yeah.
Cool. Okay.
So this sign remains there.
Yeah.
So I'm considering this negative sign as part of this -2.
Mhm.
Okay, so you get 2 on 5, so that's positive. This is 2 on 5 here, and that's your graph. That's the end of it. All good?
Yeah.
So you'll be able to try now lots of questions from 4A
Yeah.
up to all of those questions there. So you can see that question 5, 6, 7
Yeah.
is reducing this down to this, reducing this down. We saw something like that, right?
Yeah.
So reduce that to this, and you know how to graph this one. So that's why they's telling you graph this one, because graphing this one is same as graphing this one.
Right.
Yep. Now moving on to this one here. So the graph of a y squared equals x there. We're going to talk about this now.
Sure.
Okay. So when you have y squared equals x, so we know how to draw y equals x squared. This one is just a parabola.
Mhm.
When we draw this one, it's as if this is the same thing as x is equal to y squared, isn't it?
Mhm.
So this used to be up, and this used to be right. But if we now think about the x as the subject, this is playing the role of the up, okay? And this is playing the role of the right. Okay, that's swapped.
Okay.
So it's just the other way around. So you get a graph like this.
Yep.
Does that make sense to you?
Mhm.
Great. Now, if you rearrange this equation, however, if you really want to just make y the subject, so y equals to root of x, but if you take square root, you always need to put plus and minus sign at the front. So this one here is y equals to square root of x.
Yeah.
And this one here is y equals to negative square
Negative
root of
square
x.
x. Okay.
Yeah, so you get both of them. Yeah, I'm going to talk about graph of square root of x, okay? So here, first thing you need to know is the starting point. And that's that point over here. And that's given by hk.
Yeah.
Again, you know how in the previous case hk gave you the asymptotes?
Yeah. This one gives you
For
10
this one,
points.
you have to give the, it gives you the starting point.
Ah, okay.
Y equals to a root x minus h plus k. So it looks very similar, right?
Yeah.
That's the general form of the square root function. For the hyperbola, it was y equals to a over x minus h plus k, right?
Yeah.
Yeah. So number one, starting point. Number two, the orientation, of course. So I'll tell you what the orientations are.
Sure.
We have four orientations. One going like this, one going like that,
Yeah.
going like this, one going like that.
Ah, okay.
This is y equals to root of x. This is y equals to negative root of x. So if a, this is a positive, you see a is positive, right?
Yeah.
And this is a is negative.
Oh, I see.
That's
Okay.
-1 there, right? So a is negative.
Yeah.
Now this one here is y equals to negative root of negative x. So there's another negative sign inside there. This one here is y equals to root of negative x.
Okay.
So I'll give you some example.
Yeah.
So these two things are all you need. Number three is, of course, the intercepts.
Yeah.
So let's have a look at an example, e.g. y equals to, let's say, 3 root x minus 4 plus 5. So starting point is 4 and 5.
Yeah. That's the turning point.
4, 5. And then we need to think about the orientation. So do you think it's number 1 here, number 2 here, number 3 here? Oh, see, this is number 3. This is number 4.
How would you know?
Yeah, you'll be able to recognize it if just by going through some practice, but you haven't done any practice yet. But this one is positive here, right?
Yes. Oh, so
Positive.
that's A. Yeah, that's A. So it'd
And
be
that's also positive.
right. So would
So
it
you
be
need to look at plus and minus root of plus and minus x. Okay?
okay?
So the positive negative inside the root cannot come out to the front, so they don't cancel out, okay? Like negative,
Right.
negative, that doesn't mean it's the same as this one. This negative sign cannot come out to the front.
Yeah. So that would be positive or
So this would be positive, it's just like that one here.
yeah.
Okay?
Mm-hmm.
So that's the end of the graph. It doesn't have any x-intercept or y-intercept, okay?
Oh, really?
Yeah, if I have y equals to negative 3 root of x minus 4 plus 5, it'll be 4, 5 here. And the orientation is negative here, so it's downward. It's this one here. That type.
Oh.
And so this is a 4, 5. We can figure out that point because that's an intercept. So whenever intercept occurs, you have to figure it out. So plug in 0 there. We plug in y equals 0, sorry, because that's x-intercept. So 0 equals to negative 3 root x minus 4 plus 5. Now, move this whole thing to this side,
Yeah.
and you get positive, right?
Mm-hmm.
So some people choose to move 5 over there, then you get negative 5 equals negative, so there are too many negative signs.
Yeah.
I just try to avoid that.
Yeah.
You get this, and the square both sides, 25 over 9,
Yeah.
that, okay? So that's 25 and 9 plus 4. That's that value there.
Wow. Okay.
Okay, so that's the end of the graph. I'll show you something. How do you draw y equals to root of 4 minus x plus 5?
First.
Yeah. So this is when you have to, you always want to make sure that the x here is, when you have something like that, you want to make sure that the negative sign is factorized, so that you always start with x. Because negative x is negative x here, right?
Yeah.
And because it's 4, you must have another negative sign and then 4, because negative 4 is
Yeah.
positive 4.
Mm-hmm.
So this ensures, because it's x minus 4, we know that the direction is, it is going to start from 4, 5 again.
Yeah.
Because it's negative inside of the root, it's going to go in the other direction, which is like that. So it's going to go like this.
Okay.
Understand?
Yes. I get that.
And that is going to be, yeah, we can plug it in, plug in x equals 0. You can see that this is root of 4 minus 0. That's 2. 2 plus 5 is 7. See? Yeah, we can figure out something like this. Let's draw something like this one. 2 negative with negative 4 negative 2x minus 1. So how do you draw that one? You just have to get it in the right form. So that's negative 2 root, and then factorize this one with negative 2, of course.
Yeah.
Then you get
Mm.
x plus 2, isn't it?
Yeah.
You need to make it in this form. You understand? Now, that's negative 2 and then negative 1.
Oh, okay.
Like that, negative 2, negative 1.
Yeah.
Because that's plus 2, so it's negative 2. Negative 1, so it's negative 1. And then we have to figure out the direction. That's negative, so it's downward. So that negative 2 means downward, and that negative means it's to the left.
Okay.
Right? So it's going to go that way.
Oh.
That's exactly like that situation there.
Yeah. These are very abstract. Wow.
So I'll give you something like this as well. You can try y equals to 3 root 4x. Let's say 3 minus 4x. Maybe 3 minus 3x. Plus,
Yeah.
let's say, plus 2. So you can maybe plus 3. So I want you to figure it out and plot this. I'll give you some time for it. Okay.
Oh.
So when you simplify this, you get 3 root,
Root.
and you have to actually factorize whatever is in front of x. So you got to factorize negative 3, and then it'll be automatically x. That's what you always want to happen. And then there's a 2 there. So it must be something there, okay?
Yeah.
Yeah. So this will be, when you factorize, it's negative 1 there. So it's 1 and 3.
Yeah, that's what I got.
And all you have to do is think about the orientation. So, you know, it's a plus and minus, root plus and minus 1. So that's why there are 4 possibilities. Plus, plus 1, plus, x here. Plus, minus x, negative, plus x, negative, negative x. 4 possibilities. This case is plus root negative x case.
Yeah.
Which is So you can think of it this way. The one at the front, that determines whether it's going to go up or down.
Okay.
Plus, then up, negative, then down, okay?
Yeah.
Plus, then here, that's to the right or left, okay?
Yeah. So would that mean it's gonna go up and then to the right because it's negative?
Yeah, up and then to the, not right.
Oh, really?
Negative is left.
It's left. Oh, okay.
Yeah. Positive, then to the right. So it's the only thing that's, this is -1, so it's to the right, isn't it? But this one, the negative, that's to the left.
Right. Okay.
Yeah. So there are actually 8 plus and minus the sign going on. You have like plus and minus root of plus and minus x, and then plus and minus something, and then plus and minus, you see, k. This is h. Yeah. So we know the rules for these two.
Yeah.
Now we know the rules for these two, right?
Oh,
So
okay.
this one is going up and left, isn't it?
Yeah.
Yeah, that's up and left. So it's like that, okay?
Right.
Now you can figure out this one.
Oh, but question, if that one goes up and left,
Mm-hmm.
what does the H and K do then? Like, would that make it go translate to the...
H and K is what the starting point. From
Oh.
the starting point, it's going up and left.
Oh, okay. Wow. Okay, I get it. So it's like really
So this
different.
value here is 3 root 3 plus 3.
Yeah.
If you plug in 0 there, it'll be 3 root 3 plus 3.
Mm-hmm.
Okay?
Yeah.
What we actually just did here is actually 4C.
Oh.
We're going to do 4B now. So what's 4B about? 4B is about y squared equals to x.
Yeah.
From that, we get a 4C, which is about y equals to plus and minus root of x, right?
Mm-hmm.
So this one here is going to be either this one or this one.
Okay.
So this one here, so whereas this one is just one of this or one of
Oh
that.
yeah, because square root is half of square.
Yeah.
Yeah, okay.
That's right. So 4C, when you have something like that, which is y equals to a root of x minus h plus k in this form, it will be like that or like this or like this or like this, you know?
Yeah.
It'll be one of them.
Mm-hmm.
But when you have y squared equals to x, actually if we extend this one, we get y minus k squared equals to a x minus h, like this.
Oh, that's the one that I know. Yeah.
Yeah.
And plus. Yeah, okay.
So in this case, h and k is the starting point again, but you get one of these two graphs, either this one
Uh-huh.
or this one.
Okay.
So e.g., when you have y minus 1 squared equals to 2x minus 1 squared, then all you need to know, so that's -1, -1, but in this case, because this -1 is inside the bracket, it obeys the same rule as this one here.
Yeah.
So this is a +1 and +1.
Okay.
So that's to the right, and that's up.
Up. Yeah.
Yeah. So that's the starting point. And because it's 2 positive, you have this one.
So it goes up. No.
So that's 1, 1.
Yeah.
That's positive, so it's going to be going this way. If it's
Oh,
negative,
okay.
it's going to go the other way.
Oh, so it doesn't really
Sorry,
matter.
I made a mistake here because this is power 1 here.
Oh.
Yeah.
Okay. So with the 2, it wouldn't matter like how big or how small. I can just...
Yeah, so if it's positive, then it's going to go this way.
Yeah.
Negative, it's going to go the other way.
Okay. Cool.
So you can confirm that by figuring out the x coordinate here, by letting y equal 0.
0, yeah.
So then 0 minus 1 square is 1.
Yeah.
2x minus 1. And divide by 2, you get half equals x minus 1. So x is equal to 1 plus half. So that's definitely further away than 1.
1.5, yeah.
That's 1.5. And that makes sense, right?
Yeah.
So that's how you draw that one.
Mm-hmm.
I'm going to actually write a rule for this one. So I'll send you the video of today's lesson.
Cool.
You can definitely go over this again.
Yeah.
So today I'm going a bit fast.
No, that's okay.
Now, we have got y, let's say y minus 2 square.
Yeah.
And then you have a plus and minus a. Let's say there's a k here. And then you have x plus and minus x minus k h there. So h and k gives you the vertex. So number 1, the h and k give you the vertex. Number 2, plus a means this way. Negative a means this way.
Yeah.
That's it really. And number 3 is
Intercepts.
intercepts.
Cool.
So in the previous case, it had 4 possibilities, right?
Yeah.
The reason was plus and minus a, that is independent from plus and minus x. This
Yeah.
come out to the front. That's why you get 4 different possibilities. That one, that one,
Yeah.
that one. Now, as for this one, however, if you have y minus 1 square equals to, let's say, negative 3, and then x minus 1. Then obviously you get 1, 1. So 1, 1 is here. And you get negative. So it's going to be like that and like that, right?
Mm-hmm.
We don't actually know. So if it's actually plus, then it's going to be like that, right?
Yes.
We saw this before. And if it's negative,
That's gonna go the other way.
it's going to go the other way. But we don't know whether it's going to go like this or like this, right? So we
Yeah.
need to figure it out. So if I have, I can figure it out. If I let y equal 0, it's a 1 square. So 1
Oh,
equals
yeah.
3, negative 3, x minus 1.
Mm-hmm.
That'll be negative 1 over 3 plus 1, which is x. That's equal to 2 on 3, which means it's going to have positive x-intercepts. That's going to be 2 on 3 there. Anyway, so we got that situation and that situation. Only 2 situations, okay?
Cool. Yeah.
What if I have something negative here? What
Gosh.
what happens? So if I have plus 3, and maybe negative 3, and
Would it?
let's say this is 1 minus x, okay?
Yeah.
Then what we do is negative 3, and then this is negative bracket x minus 1, right? But the thing is, in this case, this negative sign can come out to the front, and it reduces this thing to 3, and then x minus 1. So literally, this guy is the same as this one. It looks complicated, right?
Yeah.
In the previous case, in the root, this plus and minus sign cannot come out to the front and cancel. But in this case, it can.
Okay.
So the plus and minus inside the bracket can just come up to the front, and once you take care of that, then it reduces down to this, then you can apply. It's a lot easier.
Oh, okay.
It's actually a lot easier thing. So I'll show you an example. Let's actually go through. So I don't see any of that case actually here, but it might show in the exam
Great.
for a trick question.
To separate everyone.
Yeah. Now, So there's a y minus 2 square equals to x minus 3. That's pretty simple. You have 2 and 3, so 2, 3, so right there, and it's got orientation like that. That's it. Okay.
Oh.
That one. So it's going to go actually like this and like that. Of course, somewhere down the track, it's going to hit there. Okay.
Yeah.
You can figure that out by plugging y equals 0. You get 4 plus 3, so you get 7.
Cool.
Okay. This one, it's a negative 2, negative 4. So imagine there's a bracket here. Negative 2, negative 4. And it is going to have a positive orientation like this.
Wait, so if there's a bracket, it's going to be negative? Wait, so why do you draw the brackets in the B?
Yeah, we just have to assume that there's a bracket here.
All right.
Yeah. Well, there isn't any bracket, but all these forms here, the original form, I just want to add bracket there just so that you're not confused.
Okay.
Because there's always this bracket here. But
Okay.
if A is 1, then there's no need to have a bracket.
Yeah.
That's why they didn't put any bracket there.
Okay.
So that one there is negative 2, negative 4.
Yes.
Okay. So negative 2, negative 4, right here.
Mm-hmm.
And go this way. Well, let's figure out whether it's going to go like that or like that. You know, we don't know really.
Yeah.
So we have to. That's why we have to figure out the x-intercept, y-intercept. You know.
Yeah.
So when I plug in 0 there, that's 2 square, and then cancel that with 4. So it's actually going to go through that point, 0.
Oh.
Yeah, that's the actual shape of the graph.
Cool.
Yeah, and for something like this one, this is the same as y plus 4 square and then 2 bracket x minus nothing. That's why just x there, right?
Yeah.
So horizontally, it doesn't move anywhere.
Yeah.
But vertically, it's moving how much?
4 down.
Down, that's right, 4 down here. And then that's positive. So it's going to
Yeah.
go like this and this.
Okay. Cool.
Yeah, no problem there, right?
Yeah.
What would this one look like? Starting from 0, of course. And that's negative there, so like that.
Oh.
But for stuff like J, K, N, I, L, you have to do some completion of
Equation
square.
stuff. Mm-hmm.
Yeah. So I'll show you.
Yeah.
For I,
Mm-hmm.
y squared plus 4y equals to 2. So you can actually put that one there. Just leave it like 2x plus 4 for now. But I need to definitely complete the square for this one, right?
Yeah.
Yeah. So I need to add 4. So I need to divide this middle number by 2. Then I get 2. Square that, I get 4. So I need to add that number. Subtract that number. And everything is preserved. And this bracket here forms a completion of square. So that's y plus 2 square.
Mm-hmm.
And 4 goes to the other side, which is 2x plus 8. Because 4 plus 4
Yeah.
is 8. Now we get this, and then 2x plus 4.
Do you have to complete the square, or can you do something? Or can you do something else?
You have to complete the square for y.
Oh,
Not
okay.
for f, but definitely you have to complete the square for. Completion of square is very important technique because in the next chapter we're going to be doing circles,
Oh gosh.
and that also requires completion of square.
Yeah.
You might want to search up some YouTube video on completion of square.
Yeah.
Okay.
I think I will. I'll have to.
That's an important skill. Okay. All right.
I know. It's just.
Can we call it a day here? Maybe we can do circle next time.
Yeah. Sure. I also sent you the exam notification.
Yeah, exam notification. I'll go through that, and I'll send you some. Yeah, you can do now for chapter A, B, C.
Yeah, I'll do that tonight.
Yeah.
That's the plan.
And we can do maybe we can do D next time. I'll give you some extra minute next time.
Oh, sure.
Yeah. All right.
All right. Thank you.